Hello everyone. My name is Rafał Gwoździński. Today I would like to present a RE model or Restaumatic model, which is an abstract language for describing data models that we use in Restaumatic. First of all, who am I? I'm a software developer focused on statically typed functional programming languages. I'm mostly interested in practical applications, so if you came here today for some more academic stuff, you probably will be disappointed. It's more like mundane, real-world applications instead. I'm trying to leverage functional programming to build robust systems, which is, I think, a big premise of functional programming, and I try to prove it that it actually is useful in building such systems. I'm currently working as a software engineer in Restaumatic, as already mentioned. And in my day job, I mainly use Haskell and PureScript. And to some extent, TypeScript, we'll see it later. Why am I here? So today, I want to present an interesting approach that we're pursuing in Restaumatic. It's not a finished project. It's not something that is already built and does everything what we want to do. However, I would love to discuss it and gather feedback and ideas from community. I think it would be very beneficial for this project to see how people perceive it and maybe to see your ideas, to see what do you think about it. I believe that your input will help us to improve, and it will improve in a way that we can implement stuff that comes from your feedback. But also, I think that maybe we will encourage you to because in the future we would like to open source it, so maybe it will encourage you to be more interested in the project and maybe in the future contribute. I'm also interested in approaches followed in different projects, and by different projects I mean the stuff that you are working on. So maybe you already solved the problem that we have in an interesting way, and that way we can share the knowledge. Okay, so maybe not all of you are familiar with the company I work on. So what is Restaumatic? You can see a small logo over here. So we build a system that provides a comprehensive solution for restaurants. So Restau in Restaumatic stands for restaurant. And by comprehensive solutions, I mean we build websites for restaurants, but also POS systems, which is point of sale systems. We manage integrations with different systems like Uber, like Glovo, or Pyszne, like takeaway. We manage the restaurants, like drivers and the ordering. We are a Polish company with Polish capital, which I find interesting because most of my colleagues actually work for companies that are based in the West, mostly. So I think that's somehow interesting. And the story behind the project is that it started as a Ruby project. Actually, it was started by a person that is here, Michał. But then a large part was rewritten to Haskell and PureScript, and the story is I think kind of common because there were problems with the bugs, and Ruby has dynamic type system, so it was easier to rewrite it to Haskell and PureScript to have more guarantees and easier development. Easier in the terms of if it compiles, it will probably work decently in production, which you don't get in Ruby. It might work okay. Currently, we leverage multiple languages and technologies, as I already stated, which makes development very interesting and sometimes challenging, which we will see during the presentation. And we are not afraid of open sourcing our solutions, so you can check us on GitHub. Maybe I'll just click it and show you. Not interested. Whoa. Not really. I have my own personal hotspot. It's called Telefon Rafała, because I'm Rafał. Go figure. Remind me later. Okay, so here you can see we only have 3 followers, so go follow us. And you can see that we have some popular repositories. Our most popular repository is PureScript Specular, which is Reflex DOM inspired UI library for PureScript, and we actually use it in day-to-day development. So you can check it. It's so it's a different framework than Halogen, which I think is interesting. Okay, but coming back to my presentation, what is Remodel? Remodel is a project that started in Restaumatic to address common patterns in our code base. basically, we want to include as much metadata as possible so that we can generate all the things. And by all the things, like currently we are starting modestly, but we'll see what happens. Hopefully we can generate everything. We want to leverage metaprogramming to speed up our development process, because if you don't have to write the code by hand, then it's obviously faster than like that's an obvious one. And it's currently developed internally, but as I already mentioned, we want to make it open source, hopefully. And this is the reason why I'm presenting it for you today, so that we can gather input and see if people are interested in the solution, or maybe there is something different and we would just like forsake this project and move to a better solution. Okay, so the name is RE-model or Restaumatic model, and what do we mean by model? So the model for us it is not just a raw data, but also metadata and declarative specification. And if you think broadly about the model, you can think about examples like relation between entities, action, and by actions I mean like changing of the state of the entities, but also some defaults and data templates. We will see this, for example, we have defaults for test data generation. Some invariants, and you obviously can have such a great type system that all invariants are encoded in a type system, but sometimes it's really hard to do this, and maybe it's inefficient, or maybe it's too much work, or your manager won't accept this solution, so maybe you want to encode some invariants in the model instead. Descriptions, and by descriptions I mean like maybe even mundane descriptions that are then generated as a comment in the code. And also translations and naming the entities in different contexts. Why Restaumatic model? The main motivation, as I already told, is to ease development process while maintaining safety and consistency. We hope that more declarative model will significantly reduce amount of time and effort spent on development. And the time is obvious one. If you generate something, it's faster than writing by hand. But also there is like a mental effort when you like cognitive load, when you have to think about all the stuff. And if it's generated, then you feel much better, and it's easier for it's easier for a developer. We think there are currently no solutions that fit our purpose, so we decided to create our own, and it was a big decision. We did some research. Maybe we're missing something. We'll see today. However, there are some interesting projects that implement partial solutions to our problems, and I will also show it today. I think some of you probably know the projects. And how do we start it? We already had a library for generating PureScript from Haskell, so we started as like Haskell types are our source of truth, and then we generated PureScript out of them. And it was our starting point, because we were like, okay, so we can generate PureScript. How much we can go further from this point. So the inspiration for us, as I already mentioned, we started as a Ruby on Rails project, was active model ecosystem. And I don't know how many of you are familiar with Ruby or Ruby on Rails, but we can think of active model as a DSL that describes models and associations between them, like relations, and encode metadata. And for example, it can generate like crude SQL or SQL migrations, and also some validations. So if you like have invariants in your code, then it will get validated before writing it to database. And this metadata that is in active model or active record is leveraged across the ecosystem. So for example, you have active admin that generates administration style interfaces, and we actually use it in Restaumatic. So instead of like creating like mundane interface, you can just generate it. And also we use inherited resources, for example. So from the specification of the model, it generates REST API, which is also neat. Another interesting inspiration that was given by Michał was headless CMS. And if you think about abstractly about our solution, it can be, you can think that it's a programmable API for headless CMS. And actually, headless CMS does a lot of things that we are trying to achieve. Like you describe a model, you describe relations between the model, and then it will generate maybe some UI for you. It will generate like data storage and stuff. So these solutions are actually kind of similar. The problem is that it doesn't generate Haskell types yet, or PureScript types yet. Maybe it will change, we'll see. Also, since headless CMS needs to support like generic content, like for example blog posts or some maybe e-commerce, it might be not optimized for specific use cases that we have in Restaumatic, because we are like kind of specific systems. So using like off-the-shelf headless CMS system might not be a good fit for us. And it's opinionated, and we already we're developing our system for like 10 years, so we have our way of doing things. And using like off-the-shelf headless CMS would require like changing the way we think, changing our processes, and also probably not very small rewrite. Like we'll probably have to fit our solution into the way of doing like headless CMS does. So we already told about some background story and about our inspiration. So now let's see some of the code and see how does it work. So the input for our model for now it's YAML files. And they contain entity definitions. And some of you might ask, why YAML files? And actually, this is the most boring part, because we just had to establish on some format. It could easily be JSON or our proprietary format. But we think that it's not very important, and we can probably switch it later. The most important thing is to having this entity definitions encoded, actually encoded. Each file has a namespace annotation, which is useful then for packaging, and you can think that entity corresponds to a Haskell or PureScript type. We will see it later. But this naming is actually problematic, because we wanted to name it, because entity generally is an overloaded term, and we would like to think about it more flexibly, because entity is not an actual data type, because we can have different read or write representations. So the naming might change, and we might the constraint that each entity is one type might be in future not actually viable. So we have different kinds of entities. For example, we can define a record. You can see the namespace. It's for our menu types. And here we have a product. You can already see a description. So if you read this file, you can probably imagine that this is a pepperoni pizza or latte coffee. So this description will then be compiled into Haskell or TypeScript, and this would be a haddock comment probably. And also record is just a mapping from mapping of attributes, and it's actually ordered. So here we have name, which is translated, description, which is translated. Maybe we will have a photo of this product, some category with the description. Yes?
Can I interrupt you?
Of course.
Awesome. So how do these types on the attributes map to the types of the records? So is translated a record, or is translated something inside Haskell?
Not only Haskell, because this record will be translated into Haskell, PureScript, and TypeScript.
No, I mean the translated type, or the photo type, for instance. Is this also a record?
No, it's a type. Translated probably means translated string, so it's a wrapper over a string, I guess. And the idea is that it will be translated differently. It could be translated differently for different languages. But we will see it in a minute. This was a very good question.
I think translated is actually a dictionary, and it's a built-in type in the DSL.
Okay.
I think, but I'm also not sure.
But it's not a nested record, that's for sure.
But it's probably not a type declared in the DSL.
Yeah.
Okay, so we have some primitive types, which we will see later. And then we also have a mechanism of external types, which you can expand. So if you have a specific types in Haskell or PureScript that you want to use, you can also use it. We'll see it in a minute. So the record is an obvious one. Another obvious one is a sum type. So here we have also a many type, an allergen. Here we have some small description. And you can see we have a different constructor with description in Polish. So we have gluten, crustaceans, eggs, whatever. We will see later how it translates to actual types in different languages. So when we have sum types, we have record constructors. So here we have a single product, product combo, or product creator, and each of them have attributes. So single product has attribute of item product, which has its own ID, but also custom parameters values, which has description. It can has also product combo, which has different set of attributes, and product creator, which also have different set of attributes. This interesting part is that we don't have a namespace here. Namespace should be in each YAML file should contain namespace, but here I think it's omitted. Another one is like we can also have sum types and constructors with anonymous fields. So for example, here we have UI element, and it has 3 constructors. One is divider, it has no fields. Another one is picture, and here we have a keyword contents, so the picture contains a photo. Another one is custom HTML, and it contains a string, probably some URL. Another one is a new type wrappers. So here in namespace, also Restaumatic types, we have a photo, and it's an image URL, and its contents is just a string. So it's just you can think about this as just a new type. And this type so the implementation in Haskell in PureScript is probably obvious. And in TypeScript, it would be just treated as a type alias. And similar here, we have type alias, and it will be treated similarly in Haskell, PureScript, and in TypeScript. Another interesting type is identifier. So we have our identifiers for entities, and to specify an identifier, you have to say for which entity this identifier stands for. So for example, product ID is an identifier for a product. This one was obvious. And we have 2 styles for like conventions for this ID. We either use int64, so the name is new type int64, or we have like menu v2 style, which is a wrapper over UUID, and maybe we don't have to dive deep into the meaning of this. So I think this answers a bit of your question. So we have a set of supported types, and you can see some of these types are very primitive, like bool, string, int, rational, and some of them are more sophisticated, for example, like maybe, either. We also have like interesting collection types, set, ordered multiset, ordered map, and here we have the small e, and this e stands for entities that we already declared. So we use these primitives plus these entities, and also, yes?
Does the tuple have to always be of the same type? So can you have a tuple of like a string and an int?
I think not, because similarly to map, the map doesn't have to be the same type. So it might be a bit of a mistake here. I just took it from...
This seems to be a grammar, actually.
This
is a proper grammar, yes, because...
Okay.
Right here you have BNF notation.
In BNF...
Actually, you define a proper grammar for these types that are supported. So, yeah. So
in BNF, you don't have to have T1, T2, and it will just take one type from here.
It's a non-terminal, yeah, and it could be matched to anything else in this list. It's grammar, actually.
Nice. Thanks, Konrad. Good one. Was there a question?
No, I was just saying this is a syntax, so we don't have to care about types T.
Yep. So if we want to if these supported types aren't enough for us, we can just specify that for Haskell we want to use restaurant ID from this namespace. For PureScript it will be from a different namespace, and for TypeScript it will be from another one. This is a mechanism for extending the set of primitives, because we can't encode everything in our DSL. And now I would like to show you the workflow for types generation. So basically, first of all, we parse definitions from YAML files. This is the most boring part, and the result is just abstract syntax string. Then we create modules for each language, and this part is actually more interesting because what we want to do here is to first of all check that all references are actually viable, so that things that are referenced by different entities actually exist and could be compiled. Also, we want to all the previous definitions are actually, we generate the code. We have 3 different backends for Haskell, PureScript, and TypeScript, so we generate actual code. Also, we have annotations for all the languages. So, for example, if you want to have some custom code in your type, then it also needs to be put into this module. So these are a couple of interesting features. Then we need to group them into packages, and by packages I mean for Haskell it will be. Sorry, for TypeScript it will be npm package, for PureScript it will be spago package, and for Haskell it will be a cabal package. And then either we write them to actual files, which is generated files, or we just generate a div to see what changes. So for example, I will show you later if I change some definition of entity, then we will see how does it change the resulting code. So now we come to real-world examples, and I try to show it with one hand, also carrying microphone. Okay, that's much easier. Here? It's all right. You have to be very careful. So we will start with allergen, I guess. Okay. Sure. What was the shortcut? Wait a minute.
I'm Vim user, I can help.
Sorry. Command plus.
Oh, like this. Got it. Is it good now?
Can you run it?
It's decent? Okay. So as I already showed, here we have an allergen type. So we have multiple constructors. And here we have, this one is interesting. Here we have derivings for Haskell. So it will derive ort from JSON key to JSON key. This is something internal for backwards compatibility in our application. And here is the extra code that I already told you about. So here we want to get an ID from allergen. And this is actually a bit weak because in PureScript we have very similar implementation, which means that we should probably abstract it, but it's not done yet. In PureScript we have derivings for ort and JSON key. And also here we have allergen concentration. So we have this definition, and now we probably want to see how does it look in Haskell. So, yep.
Do you have any plans on abstracting those allergen concentrations into a single representation? I'm thinking of a case of a different allergen contents in Haskell and PureScript.
I mean, in broad scope, we want to abstract everything, but we don't have enough manpower to be really. We have to be.
Probably you can do it right now because as far as I know, YAML package has support for these macros,
Like Anchor, it's probably called Anchor in YAML?
Probably, yeah.
Okay, so we could probably use...
This is, I think it's probably doable, but I can tell it right now for sure.
Yeah, we have this special syntax where you have the similar the repetition, but this one is a bit tricky because it's the syntax is a bit different because you can see we have here lambda case and here we have this PureScript case. So
I see.
This is embarrassing. Maybe there is some hack in YAML for this one. We will see. Okay, so we probably want to see okay, so at first we already see that it's auto-generated, and it really is. I didn't write it by hand. Here we have some pragmas. We generated some imports. Here we have a different type, allergen concentration, which was also defined in this file. Here we have our code that was just pasted. Maybe the ordering isn't most fortunate. Also, we probably would like to have space here. But here we can see our data, allergen, and all the all the types, all the constructors, as well as all the derivings. So here are just boring show, eq, ord, generic. Here, how to serialize it from JSON to JSON. Here we have our custom type for PureScript and something with logging. Not very interesting. So here we will see a PureScript representation, which is kind of similar. So we also have imports. We have PureScript style of deriving and instance definitions. Here we have allergen concentration. The code is also just pasted, like the custom code. And at the bottom, we will see the data type. And now we want to see a TypeScript definition. A TypeScript definition is really simple. So here we have the doc string, and we just have some type with the strings. Okay, and now we would like to sorry?
You don't have this toInt function?
I'm sorry?
In TypeScript, you don't provide this toInt function?
It seems that it wasn't necessary for this, so it wasn't implemented, I guess. So we if you look at the definition of the type of the entity, actually, it was only done for Haskell and for PureScript, and we don't.
No, I'm wondering if this is all, kind of error prone. If you miss the numbers in different languages, then there's errors on the.
It might be error prone, actually. This one is like, I mean, if you miss something in your entity definition, it is error prone. So with the definitions, you have to be like entity definitions, you have to be really careful, because if you mess up something, these are our core types. So we want to be very careful when modifying it. And I'm not sure if it answers.
It's not entity, it's like you paste a custom function in here, and I'm like wondering.
Okay, so.
When you use it, like it's kind of, well, seems risky just to use it.
Okay, so once again, we treat entity definition like this is definition of the constructors, of the derivings, all the custom parts, but also the code that we just pasted. And obviously it is error prone because I can easily have like, I don't know, 2 official IDs, and now it will not compile, right?
Well, but it's more interesting if you switch glutton and X, for example.
Yep. So it's not actually type safe, and we should generate it. I'm just showing you like the way it is now, but it should probably be improved on. Okay.
Actually, this toInt or fromInt probably as well seems like a good candidate for extending this.
Definitely is.
Manpower.
Yeah, not only manpower. I'm just showing you like a solution that it isn't perfect. It's like work in progress, and we are trying to build it so that it like fulfills our need. And now this is the hairy part of the solution.
This is the escape hatch.
This is the escape hatch. I can put.
But you can put any code in here.
Yes, I can put any code here, and it will be pasted. Yes, I can do anything here.
But you can put unsafe IO in any Haskell module. So, I mean,
Yes.
No, I'm not criticizing.
I mean, I would criticize that because this is like we don't want to do it in the sort of final version of it, right? But at the same time, we want to have an option to add module to the code to the generated code as easy as possible.
I think it's better to have such an option because you never know all of the use cases.
Yes,
Yeah.
it is unsafe,
Yeah.
and also there is like if you see this kind of,
Derive this toInt or something?
I think it could.
I don't think it doesn't here. This is in TypeScript. It's just a list of possible strings, not an enum.
It would if it were an
That's my
enum.
question.
No,
Because I didn't solve the definition for the TypeScript. So how do you do it in TypeScript?
We don't.
Well, you said that he may not need it in TypeScript, so yeah, that's kind of answers the question.
No, you can't get an index of a variant at runtime in TypeScript. I don't believe you can.
With this, you can with enum, but it's not
Yeah,
an
with
enum.
an enum, yeah.
Maybe we can talk about it offline, okay? Because I don't think it's the most interesting part from this presentation. So
But actually, if you are like, if there is a problem with this code, it's not just that you can change one or the number of the allergen, but look, this is a code inside of YAML. Why is nobody commenting that?
Actually, multi-line string, you can put anything. Yeah?
Yes.
Yes.
Boolean,
YAML inside your code inside YAML. Yeah.
Yes, but after generating the types, we try to compile it. So I think if you put anything, the compiler won't let you. This is yeah. So we still have some security checks. Okay, so this was allergen, and another one it will be restaurant. Restaurant. So here we have a bit more involved type for.
Could you zoom it out?
Yes, I will do this.
Because I'm just trying to squint,
Can we see the whole thing?
I thought I have some
Oh,
issues
sorry.
with my e-sites.
Oh, sorry.
Probably you want to comment.
How it works?
Yeah.
Oh, okay, we got it.
Nice.
Okay, so here we have a restaurant, which is a record type, and here we have multiple attributes. This one is pretty boring. But you can see that we also have some mappings here for database. So if you have like manual URL, it will be mapped to a column that's named manual URL. Actually, it's kind of small. Maybe maybe now it's a bit better. What I want to also show here is here we have mapping for tables, restaurants. Here we have some Haskell notation. And here we can see a quite cutting-edge feature, which was developed by Maciej like 6 days ago, was last commit. It's a factory. And what I was talking about, the test data, you can see here. The factory is a feature we want to tie our model description with generation of the test data. We want to specify defaults for a given entity, which then can be manipulated for a given test case. And the problem that it resolves is that a lot of the times you have very long declarations hidden somewhere in test suites, and sometimes it's hard to get good defaults or good invariants in them. So we try to tie it, to tie the test data more to the model, so that it's easier to see what are the same defaults, and then manipulate it with an API. Automated testing. So we either want to have like the in-memory representation for some, I don't know, maybe unit test, but also this is the point that I'm presenting right now. Also, we can store it in that database. We already see that there is a mapping between our entities and the database. So we would like to store it in database and use it for some end-to-end testing, for example. So we will pre-populate database with the same defaults, hopefully same defaults, and then run tests on it.
Did you use any probability-based testing in order to generate this data, or anything that will I can get the way in which you get this data out. I know you will probably find some factor, or as you can call it, right? But do you use any RNG for that?
We use property-based testing, but sometimes when you have, like, for example, menu of a restaurant, the data is very, very large, and describing it in like property-based testing and generating is sometimes really hard, because we want to have some invariants, and we don't want, it's very involved to have very like nested structure that is properly generated out of property-based testing framework. So it's easier for us to have like the same defaults that will test some like more popular test cases in end-to-end tests, instead of trying to prove that it works for each generated case, especially in end-to-end tests, which in end-to-end testing you don't want to have like all the possibilities that there are. Okay, so and I would like to present how the restaurant actually works in PureScript and TypeScript. So I think we don't have a PureScript type, so it's only generated Haskell and TypeScript. So in Haskell you will have this boring record, very long record. And in TypeScript you will have in Haskell you will also get, and you can see that for example, maybe here is treated that way. In Haskell it's obvious, and here we have in TypeScript, sorry. In TypeScript, you have either a number or a null. This is the way we represent maybe type. Yep.
And for imports, I assume you figure those out based on the declarations that are included in YAML, right?
Yes, we have like in order to have imports, we have an algorithm to see like we need first of all we need to check if the references are correct. So if you reference something that actually don't exist, then you will get an error, and then we have to prepare the list of imports. I'm not sure it's working like it's simplified in TypeScript. It's more interesting in Haskell, where you actually get all the imports, and some of them like are imports that you get from the primitive types, like for example this from JSON to JSON, and some stuff is taken like from entities, actual entities. Also, in order to convince our colleagues to use this library, we try to do some dev experience stuff, so that is like not very rough on the edges. The first one is the diff of generated changes. So in order to see this, let's say that we have a restaurant. Probably have to, okay. So here we have our, oh, this looks bad. So here we have our DSL command, and you can see that we can generate code. Obviously, we can print definitions dependency graph. We will see it later. But also we can generate diff. So let's say that I have a restaurant, and we have delivery reviews. Let's see that if I have some. I already have some changes to allergen. Sorry. Oh, already have some changes. So I added this crazy new allergen that is called something, and let's see.
It's always something.
It's always something that hurts you. Okay, and we can see that something appeared in these generated types. Actually, something appeared. So currently we generate this kind of like basic diff of like what changed in actual files, and later I will show you that we have some interesting ideas for future. What can happen if you treat diff like semantically, not only like in a generated code. Another dev experience is dependency graph. So this one is a bit crazy. Wait a minute. So okay, so we have a lot of dependencies, as you already seen. So if I go the DSL graph, it will generate this crazy graph with output, and I already pasted it in some.
This is in dot format, isn't it?
Yes, it is in dot format, and you can see that we have crazy dependencies. Maybe it's not the most readable graph in the world, but it's.
Get you the graph with options to actually make it.
I did it like 5 minutes before like coming here. So I just pasted into like first result I got from Google query. So it is what it is. But you can see our commitment. We have a lot of types, so we really like types. And another one was we are currently working on LSP for major editors. I think it works for Vim quite well because Maciej is working with this. I tried to configure my Emacs for the LSP, but somehow failed. I did it like today, so sorry for that. And the VS Code was the most challenging because you have to write some JavaScript and TypeScript. And I tried to implement it, but it's still a to-do on my list.
Isn't LSP the idea that you only write it once?
Yeah, but the plugins, you have to have plugins for each editor. So we have.
VS Code actually the start of this?
VS Code?
VS Code was the start of LSP, really.
Yeah.
But you need to register it, kind of.
I mean,
Someone needs to use it.
Like in Vim, you just write a few lines of configuration saying you are done.
yes, and
You have to create a plugin package.
Okay.
yes, VS Code was the most involved, and like Emacs and Vim worked like right off the box. The only thing that we have to do was to provide the implementation. Where is this SRC DSL? The thing that was right once was we have written this LSP server, which was like, I don't know, 200 lines of code and like 3 lines or 4 lines in Emacs, and it just worked. Okay, so we have the dev experience, and now let's talk about the future. So I already told you about the diff, and it was the simple diff on generated files, but we would like to also think about the model modification in a more abstract way, because everything is abstract when we think about this. And this thing would need to work on semantic diff. So instead of answering a question what changes in the actual file, we would like to see the semantic change. And if you see the semantic change, we would like it could have like very interesting properties, because you can then generate the code that resolves this change. And the first step for this one, because we don't have as much resources and we try to think incrementally. So for example, the first one, like MVP, could be just generate a warning. If you create something that will not be backward compatible, then the developer would get a warning. And then later we could generate like whole conversions, for example, whole migrations, and it would be much nicer. So in order, like when you don't have a very big team, we try to think like incrementally instead of like trying to build the last step all at once. And we have a lot of things that are on our wish list, and we will see how the situation unfolds. First of all, we would really like to generate the UIs. So it's similar to Active Admin. I can actually show you, like, because it's really neat. If you have like Active Admin, the idea behind this is that you create beautiful interface. Maybe it's not that beautiful, but what's interesting is that you have like this kind of specification, and then you generate this interface. And if you think about this, like, this could be like forms that can be used in different contexts, and like administrative forms for entities, like this super plain boring, you have a list that you can filter something, search, and you have some available actions. It would be really beneficial, because I think nobody likes to create this like by hand. Another one is to express invariants. I already mentioned this, things that are hard to like encode in the type system. And then maybe we could automatically create validations, and it works for Ruby, so why not for Haskell? Also, data access permission could be encoded in the model. The very ambitious project is to create query language, similarly to, I don't know, GraphQL or something better. Also, automated testing. If we think about like having entities but also having actions, so the model of the actions with the relation could generate the test input and output. That would also be neat. And then the relation we will define could be storage agnostics. We could do traversals, something also similar to GraphQL. So these are the ideas that we are trying to like think of and maybe work on if time permits. Okay, so I already showed you our solutions, and it was created because we didn't find any solution that was already on the market that like fulfilled our needs. So here we can see what we were considering. First of all, use single language. This one is obvious, right? The problem is that it needs to compile to JS, and I'm not sure that Haskell has like very convincing JS story as of now.
But 9.6 will have, right?
Yep.
How was deployed 1 week ago, right? With JavaScript backend.
Like when we started, we weren't convinced. So the Haskell, and we have like quite a lot of code written in Haskell. Also, generated JavaScript performance might not be optimal, and we already like used TypeScript because we have a problem where bundles generated by PureScript were too big in like parts of the system that performance was crucial for. Choosing one language for whole system makes it very opinionated, and like for example, I've seen this with F# or OCaml, where if you do this, you're an F# or OCaml shop, so you only like your employees are F# or OCaml developers, and it has its strengths, but also it ties you, so it's like a very big lock-in. We just write everything in one language. And in order to do this, like for us, we would need to rewrite a significant part of existing code base. If we choose Haskell, let's say that it has like convincing JS story, then we would need to rewrite a big part of our PureScript code, which would be really, really painful because we invested a lot of time in it. For example, we created specular. Another interesting solutions, and I don't know if you already know this, is IHP. Let's look at their website. So basically, an IHP is marketed as a type-safe web framework for builders. We are builders, so we are interested. It's type-safe, so it's nice. And it's a Haskell framework for non-Haskellers. I mean, this one, maybe. I consider myself a bit of a Haskeller. But it is database-centric, and if you look at their videos, they are, for example, they create a schema, and from database schema, currently they use only PostgreSQL. They create types, they use Haskell and Nix underneath, which is interesting. And it seems like they are really good probably because the ratings are high. So it's a full-stack Haskell framework. It's focused on rapid application development. Everybody wants to be rapid. It generates Haskell data structures and types from DB schema. That's one is neat. It generates DB queries and migrations. We want to do this. Why not use IHP? The problem is that it would also require a significant upfront rewrite. So we would need to convert our way into IHP way, which is already batteries included and very opinionated. And it's opinionated, but I think differently than we are. So there would be a lot of work put to like change opinions and change all the code that is already opinionated. I don't think it will be easy sell for the management in our company. Another one is a PureScript bridge. I guess probably a lot of you know about this. So PureScript bridge is we already had the similar solution. It's just translate your Haskell types to PureScript types, which means that Haskell will be our source of truth. It should, in theory, work for almost all Haskell types, okay, in theory, including type constructors, nice. It's simple and effective, but it works just for 2 languages, and it's hardly extensible. I mean, if you want to use TypeScript, then we have to also have a TypeScript bridge, which translates from Haskell to TypeScript. And if we want to have another language, then we will have to go this way of having another like bridge. It ties us to having Haskell as a source of truth, and I think it has like some advantages, but also some disadvantages, because then we will have to like think in terms of Haskell when developing, and not all developers in our company think like Haskell first.
And it might also be just a thought. I want to check if you agree. It might be hard to express certain types in other languages, right? Haskell is very expressive, and it might not be possible to do the same like in TypeScript.
To some extent, we already do this, because when I showed you, we think in terms of records and SAM types, so we already think a bit Haskell first, but we don't want to like tie everything to Haskell, I guess, and generate everything out of Haskell. For example, at this point, it's hard to get data from hot comments, and we want to annotate our entities. We want to put a lot of metadata and hot comments. I don't think it's a viable solution. Yesterday, Maciej told me about Haskell annotation pragma, which might work, but I didn't do much research into it. I think it might work only for top-level definitions, so I don't think it's fit for our purpose. Another solution is to have API specification as a source of truth. So, for example, you can have like OpenAPI or protocol buffers or GraphQL. And there are already projects that generate types from this specification, which is neat. But the model on the wire is less expressive than we need. So it's a simplified model and generate. So, for example, we use collections such as map and set, and on the wire we only have an array probably. So it's a bit pity that you don't have this. Also, the SAM types will be a bit cumbersome, and the lack of generics. JSON schema generally is extensible, so we could annotate it, and in theory it could work, but I think it's not fit for our purpose, so we just didn't go that way. So these are the solutions that we considered, and the summary of like this project of the work that we did so far. Benefits. We create a solution that fits our purpose, and it gives us a lot of freedom. We already have a somehow opinionated code base, and generating this solution lets us like move forward with this opinion, and we don't have to fit to some other solution that might not be optimal for us. It is somehow language independent. I mean, I already told that we think a bit like in a Haskell or PureScript manner, but we don't have to tie fully ourselves to having source of truth in Haskell, PureScript, or other language. This one is big because our solution can be developed and deployed incrementally. So we don't have to do a major upfront rewrite in order to change our solution. As you already see, we have some escape hatches. We can migrate our types partially into our solution, and it's like an incremental buy-in. We don't have to like dive deep, like let's go do IHP. We can just move in our own pace. It automates tedious work, which is like great for developers. Sometimes you don't want to like have all the stuff in your head, like all the conventions that you have to follow. It's always easy when like machine generates it automatically. This one is obvious. It enforces our conventions. So instead of writing documentation about what is our convention and how each type should look like, we can just encode it in this library, and then it is auto-generated. So you don't have to force developers to like obey some rules, because they are obeyed automatically. And it is a fun project to work with. Actually, I did some implementation of the stuff that I showed you, like with Maciej, with Michał, and with Konrad Lewandowski. And it was really fun. I really enjoyed this project. So we have the benefits, but there are also challenges. Projects like this requires very thoughtful and creative work. I mean, if you want to encapture abstractions and patterns, you really have to be very careful, and you really have to like think through all of the possibilities and how it will unfold in the future. Because if you do mistakes in like this core library, then it will be hard to change it later. So you really have to be like confident that the changes that you are doing will be good in the future, and you really have to like put so much effort into like recognizing the patterns and like programming it. Also, it's not only about the code, but also docs and tutorials, and this sometimes can be a boring part, because first of all, you have to do like the implementation, all the libraries and frameworks, but then not everyone likes to like document it and do tutorials, and it's also like sometimes this work can be a bit less fun, but still it should be done, because if you want to convince your colleagues that they should use it, you have to provide them a good story, good documentation, good tutorials. So this is something we should also consider. And I think the most challenging part is actually moving to open source, because it's not like you just put your project on GitHub and it's done. Actually, it requires also a significant amount of work. First of all, our solution is opinionated, and we would like to see, for example, today, if it is a general solution, if you have this problem too, and if our library can solve your problems. Because if not, if it's just a solution for our problems, then it means that it won't be very popular. Building community. So in order like to move it to open source, we'll probably have to have not only people from our company that are active, but also other people that recognize value in this library and they are active. Marketing, and by marketing I mean if you want to sell it to your manager, if you want to sell it to your dev lead, you need to know what purpose does it fulfills, and what are the benefits, and what value can you get from this. So we have to provide the good story behind this. I hope that this presentation was like a good beginning. And also the maintenance, it might be also a bit of a boring job. Like you have to maintain it, you have to actively provide work in order to have like less bugs and new features. Okay, so thank you for your attention. I think that's it. Now we can go to part of question and answer. Now we can go to part of question and answers and discussion.
So I have many questions, as is usual. So first of all, I don't think you should force yourself into thinking that like going into open source needs this code to be great. It doesn't. It's all like we release open source code all the time, and it's just like totally up for us. And if someone else wants to make it general, great for them. If not, I mean, it's open source anyways. That's one thing. But the actual questions is like, first of all, how do you test the generated code? I think you briefly mentioned it. And also, how do you test this generation scaffold, so that generator itself? Do you do any special testing?
Yes. So if you think about testing, like the first test, if it compiles, right? So if I put some stuff that is like absurd in the, for example, this escape hash, the solution will not compile, so it won't work. Also, we run like normal test suites on the generated code, because you generate types and then you can run usual test suites. And when
you compile every language that is a target. Every target language is
yes. Yes, and then if you want to see a test, if you want to see test of actual, okay, so we call it DSL. Everything in Haskell is DSL, so we change it to a remodel. And we have multiple tests, for example, for our code generation, for factory, for parser. Let's start with something that might be.
These are kind of golden tests, right?
Yeah, these are kind of golden tests, and you can see the structure. Let's see something basic. So here we have a definition of a product. It's very simple. Here we have AST that is parsed to. Here we have generated Haskell code. And here we have generated PureScript code. I think there are no tests for TypeScript in this one. So if you break something, then the test will fail because you either change AST or you change the resulting code. So this is basically how our test looks like.
Doesn't this mean that if you add a field, completely optional field, you would have to rewrite all the tests because this field would show up in AST?
Yes, we have. Then we will just have to accept all the tests that changes. So our test suite is not that big, so I don't think it will be a very big problem. You will probably have to accept all the tests, but yes, that means that it will change. It's not it might not be optimal solution.
And you might need some power.
Yes.
Yes. I mean, to develop the library and to my computer.
One suggestion, I'm thinking if other front ends of your DSL would be worthy. For example, let's say, do you know the whole format or the whole lang?
Yes.
This is kind of configure language that is mainly not actually complete, but is there's like no room for recursion, but this format allows you to use all the local bindings and to let's say wire it up more reasonably than, like, let's say in YAML.
Or DOR or JSON is the most boring part, and the most like challenging part is actually the building the features. So we started with YAML, but it doesn't have to be YAML. We can, for example, have different front ends. It's not the part that we are focusing right now, and we don't find actually working with YAML that challenging.
I mean, like, not actually. I mean, the whole can give you another opportunity to your DSL. For example, you can create a function that will create your, like, you can reduce the boilerplate that you introduce in such configuration, such formats can be significantly reduced by using, let's say, some functions that will like factor some parts out in order to, I mean, regarding the whole language, the whole configuration language. This could be an option, I would say. I mean, by these arguments that I said. So
So our project already is concerned with reducing boilerplate, and we find that our description of entities are very succinct, and we don't have a lot of boilerplate in them. If we see that there is an occurring pattern, for example, here today we just see like two examples. If we see that there is a pattern that could be like abstracted away, we will probably do this. But for now, YAML is sufficient for us, so we didn't focus on that part. But we are not very like emotionally tied to YAML. We just like, this is a very boring description of an entity, and it's not our main focus right now.
Yeah, you are probably right, because still whole infrastructure regarding these values and other stuff is related to ISON and
So you partially answered already this question, but why did you choose to do it as an external DSL instead of embedded DSL in Haskell? Like, because for what you have shown, I think it would be easier to implement as an embedded DSL.
What would be the difference? Because I don't see the ease.
So you wouldn't, for example, you wouldn't have to write Haskell code generator on.
But you would have to somehow get this, extract this syntax tree to generate PureScript and TypeScript.
Easier to do with template Haskell than generics. So because I've seen like solutions like this or similar to this implemented in Haskell using embedded DSLs, and so your future planned features are probably more difficult to do in an embedded DSL, but just PureScript and TypeScript code generation would probably be easier done in embedded DSL. So easier, like you don't have to write all this code generation for Haskell. You don't have to write this parsing stuff for the format and so on.
Could you name a specific project that does similar thing? Because this part is very interesting, because we try to recognize project that does the same stuff that we want to achieve.
I don't know if it's open source yet, so I can.
Persistent. Okay.
Kind of, but this is not the same. But similar thing. You have some DSL put in template Haskell, then it's this whole quasi quotation is then converted to some real types, and
so to answer your question, I think the parsing of YAML and the Haskell generation isn't the most challenging part. The features that we want to implement are the interesting part, and I think the parsing is super boring, and the code generation for Haskell also wasn't very.
But it started as a.
Yeah, it started that way actually, right? Because we had Haskell and then we generated PureScript, but we want to move forward from this approach.
Yeah, because actually you reinvented the syntax for Haskell types inside YAML.
Not only Haskell. This is a common part for Haskell, PureScript and TypeScript. So it's not only Haskell.
So maybe a question.
So algebraic data types.
Yes.
So the question here is, why did you make the decision to move away from the in Haskell representation into separate files, a separate representation in YAML?
I think it was mentioned on one of the for the PureScript bridge. Here. I think this is an answer is here, because it's hard. This annotation of the metadata would be harder because we will have to encode it in types, I guess, in Haskell types, and we find it easier and more extensible if we have our own format. This is our approach.
And also Haskell is slow to compile.
Oh.
And you want to be really responsive with that, because.
is it?
This one was controversial.
It take longer, compilation.
So what I have seen we can talk about later. Perhaps I have seen the solution at the one company that have the TypeScript types generated Haskell, and it's all in Haskell. It's embedded in Haskell. But the front-end people complained that they don't want to depend on Haskell code. Yeah, so that's maybe.
I already stated that not all people in our company are Haskell developers, so this might be a tough sell if you want to be Haskell first always.
Sometimes you may need like two different representations in Haskell. It may be clearer to have it generated rather than have it written in Haskell to transfer from one to another.
But your generator is in Haskell.
Yes.
When you do a diff, what do you do diff it with? Previously generated code?
The diff, you diff it with previously generated code and your changes.
Okay, so in theory, if I want to step on my own toes, then if I alter that code, I get completely gibberish diff. If I alter what it previously generated.
Yes, if you alter the stuff that is headed with auto-generated, you probably shouldn't do this. Maybe you should write a big warning, maybe something like this.
So to build up on this question, because I think you mentioned that you can already store your types in the database, and how do you map that to the database?
How do you map?
Because you said for test that you could generate some data and put it in a database.
Yes.
And that's happened magically somehow.
We have a mapping encoded for the database tables and database columns. So we have this logic, but this was actually implemented by Maciej recently, so I might not be up to date.
Like another target, like Haskell, PureScript, SQL or something.
No, it generates a JSON representation that is then loaded to database.
So the migrations are not auto-generated. You define tables somewhere else.
Yes.
SQL.
Yet.
Yeah.
If there's no other, I have another one.
No problem.
A bit different. So I wanted to ask about the implementation details a bit. So when you generate for the target language, do you use some AST and then print it, or do you use string templates or something?
We have an AST representation. Actually, probably I can show it to you. It's been a while since I worked on this project, but I hope that. So basically, we have different code generation for Haskell, PureScript, and TypeScript. Let's see. I mean, it probably will look. Oh, this one is boring. It will probably look a bit ugly. But here we have our logic that. See, here we have some default pragmas.
It's a bit small, so.
Oh, yeah. Sorry for this one. So here we have some pretty printing logic, some default pragmas, write some declaration. Here you have type alias, new type, data declaration. So this is some.
Yeah, basically, from your AST representation, you generate types directly. You don't go through some Haskell AST.
No. We have our own representation, and then we just pretty print it. So it's not like we use Haskell libraries.
And how do you find that approach?
I think for our solution, this is a simpler approach that just works. So we didn't find it very hard to do this. Also, we had some discussion about having different backends, because if you think about Haskell and PureScript, they are pretty similar. But we just copied Haskell backend and create PureScript solution. It's a bit different, and maybe, but very similar. And maybe in future we can do some general solution. But
So now a bit justification. I asked this question because, well, now that project from the GitHub, they have this big Haskell semantic project, and they actually use they built the AST for generated Haskell code, but later regretted that decision. So I was wondering, what's your approach?
we are.
Say that if they would do it again, they would use this approach.
Mine approach, ours approach. Okay, so it's encouraging because they later regretted it, and this project is kind of fresh. So you should ask me later. We should talk in a year or two, and then we'll see.
So we had a project like that that's been running for the same approach, and we like it. Although it kind of looks ugly because you want to have like a proper AST and do it right. It's just in practice, it's much easier.
What are the features of the editor support for LSP?
So the LSP is a bit lacking. I think, Maciej, can you help me? Because it just reports errors. We try to make it so that it could jump to definition, because when you have a lot of YAML files, it would be nice to have the jump to definition, but the editor support isn't like there yet, unfortunately. But it's a tough sell for like our colleagues, so we want to make it like a good story, like good support story, because if you have like raw YAMLs, it can be overwhelming when you have a lot of files. So it's a part for like later.
It's unusual to have something like this even for like such a small language. So it's
okay.
It's already quite
impressive.
Okay.
And when generating, have you considered generating completely ugly, just compiling syntax and putting it through some external pretty printer?
We did consider it. I mean, I think, do we use Brittany right now? Or for example, for Haskell? No, we just generate it and it is as is. Because we had an idea to have like auto formatter run on our output, but I'm not sure.
So no, we don't format it.
Yeah, it's a bit ugly, but it's not that bad. I already showed the generated code and it's totally readable, so.
Actually, for these kind of tasks, I mean, pretty printing and other stuff, you could use pretty printer libraries in Haskell. There are a lot of these. For example, pretty printer, as this is the name of one of the libraries, will probably fit into these scenarios that you want to use. And adding to that, you can also annotate your generated code, so you can provide some styles to it. You can even export into other format, or you can, you know, like this syntax that you are pretty printing could be also annotated, well formatted. You can compress this representation to one single long string that is even not properly formatted, but you can also pretty print it. There is a lot of options to that.
Sure, I'm sure there are a lot of options. As I already stated, this is a kind of fresh project, and the pretty printing part also isn't like our focus right now, but maybe later it would be really beautiful.
This is not matter of being beautiful or not, but like this is kind of matter to do not allocate too much text in your heap or other stuff that you want to avoid during translation from other format to another.
Okay, I think maybe we can just wrap it up, because people want to probably drink beers.
We can talk this offline.
Yeah, sure, we can talk about this offline.
Yeah, so thank you a lot.